Hi students, now we are going to do a problem to find out the rank of a matrix. Okay. Determine the rank of a matrix 1, 2, minus 1, minus 2, minus 4, 2 and 3, 6, minus 3. This is a 3 by 3 matrix. We have to find out the rank of a matrix. Before going that, this is a notation. If A is a matrix, then the rank of a matrix is denoted by R of A. This is the notation for rank of a matrix, and we know that rank of equivalent matrices are same. So we are going to reduce this matrix as a row reduced echelon form using elementary transformation. So that is the first step. Now we have to keep in mind that what are the steps, what are the conditions for a row reduced echelon form? That is, we have to make the diagonal elements as 1. That is our aim. We have to make the diagonal elements as 1 and all the elements below the diagonal elements must be 0. Then we will get a row reduced echelon form matrix. Okay. Now here I am giving the matrix as name A. Let A is equal to, matrix A is equal to 1, 2, minus 1, minus 2, minus 4, 2 and 3, 6, minus 3. So first I have to make the first element as 1. Here the first element is already 1. So there is no need to change that element. So the first row, we have to write the first row as it is same. So I am using equivalent symbol. We are reducing this matrix to row reduced echelon form. So we use instead of equal to, we use equivalent sign. So this is equivalent sign. This is equivalent to first row 1, 2, minus 1. Okay, now we have to make these two elements 0. So we have to make the elements below that 1 as 0. That is our next step. So for making this minus 2 0, we have to multiply this 1 by 2 and adding with this row, this element. So we get 0 here. The same procedure have to be done for all the each and every element in this row. Okay, every element we have to multiply by 2 and subtracting and adding with the second row. Okay, so here the transformation is R2. R2 gives, or R2 is equal to, we are multiplying this R1 by 2 and adding with this R2. So I am writing R2 plus 2R1. Then we get this element as 0. Now we have to make this 3 as 0. What is the procedure? We have to multiply this element, this row by 3 and subtract from this. So R3 gives R3 minus 3R1. Okay. So what is this row? Here minus 2 plus 2, that is 0, and here we have to multiply this by 2, this element by 2 and adding with this we get minus 4 plus 4. Okay, minus, so multiplying this we get 4, so minus 4 plus 4 is 0. So here also 0, here 2, here the element is 2, multiplying this element by 2, so 2 plus minus 2, this element become 2. When multiplying minus 1 by 2, we get minus 2. We have to add these two elements. So 2 plus minus 2, that is 2 minus 2, that is 0. Okay, now I am coming to the third row. What is element here? 3. So for making this 3 as 0, we have to do this elementary transformation. So R3 minus 3R1, so we get 0 here. Okay. Now here it is 6 and we have to multiply this element by 3. We have to multiply every element by 3. So we have to multiply this element by 3. That is, here it is 6 and 6 minus 6 is also 0. Here minus 3. We have to multiply here with 3 and minusing and subtracting. So minus 3 minus minus 3. That is minus 3 plus 3. Minus 3 plus 3 is also 0. So look at this, both these rows become 0 when we apply this elementary transformation. So reduction completed, and this is equivalent to our first matrix. Only 2 row transformation we are applied and we got the row reduced echelon form and the rank of this matrix, and I named this matrix as B. is matrix as B, and matrix A and matrix B are said to be equivalent matrices, and we know that equivalent matrices have same rank. So rank of A is equal to rank of B. Okay, but what is the rank of B? Rank of the matrix B is the number of non-zero rows. Number of non-zero rows means here only one row contain non-zero element. Other two rows are zero rows. What is the meaning of non-zero row? If at least one non-zero element is there, then that row is said to be non-zero row. So here only one non-zero row. The other two rows are 0. So the rank of this matrix is the number of non-zero rows, and that is 1. So rank of B is equal to 1. So rank of A is also 1. Thus we get the rank of the matrix A. So using some elementary transformation, we reduce the given matrix as row reduced echelon form, and the first matrix A and the last obtained matrix are equivalent matrices, and equivalent matrices are of same rank, and rank is the number of non-zero rows in this row reduced echelon form matrix, and here the number of non-zero rows is 1, and so rank of B is equal to 1, that is equal to rank of A. So the rank of the given matrix is 1. Okay, thank you.